Hey everybody, welcome to part 4 of my Roguelike and Godot for Complete Beginner series. Today we're going to be looking at a new node called the animation player. The animation player is a powerful node that not only allows you to animate your player, but also control basically every property and function within that character as well. Today we're going to be keeping our use of it relatively simplistic, but this node can basically be used all on its own to make an entire game. To start, go ahead and go to your swordsman character, and we're going to go ahead and just add a child node, animation player. Once you're in this screen, you'll see that we have a button to add new animations. So we're going to go ahead and do that here. And we're just going to call this one idle. This is what the player is going to be doing when he's just standing there. Since idle animations are on repeat, we're going to go ahead and tick this animation looping. This will keep our animation playing over and over. Now we want to go ahead and add our frames to our animation track. To do that, we're going to go up to our sprite 2D, and you'll notice that next to every single property in here, there is now a key. What this allows us to do is, for each frame in our animation player, we can key certain properties of our nodes, which in the case of animating our player, we're going to be keying what frame of the sprite that we're in. So if you remember, our sprite idle animation has 8 frames, which you can see here by clicking on this actual texture property. So I'm going to go ahead and set our animation length to 0.8 seconds, and I'm going to use 1 frame every 0.1 seconds. I'm also going to go ahead and set snapping down here to 0.1. Basically, this will allow us, if we zoom in, to have our track, make sure that you click apply snapping to timeline cursor. This will allow our track to snap to our 0.1 seconds where we want our frames to be keyed. So now over at our sprite, we're just going to click this key, and it's going to add the frame property to our animation track. Go ahead and just say yes to the creating the reset track. And then we're going to iterate through every single one of our sprite's frames. So go ahead and jump forward 0.1 seconds, increase to frame 1, and then go ahead and key it. And then you'll notice that it's going to try to follow a trend. And so it has already moved it over again, 0.1, and it has increased our frame numbers. So you can pretty much just mash this key. You'll have a fully animated character. To make sure it looks right, you can just move this animation track down a little, hit our play button right here, and you'll see that he is going through that idle animation. Now, I also want to add a running animation and an attacking animation. However, something really strange about this asset pack is that instead of having this character's entire animation set on one sprite sheet, they have made a run sprite sheet, an idle sprite sheet, and an attack sprite sheet, all separately. So in order for us to include all these animations on our character, we are going to have to switch out our sprite's texture in order to have access to all of those animations. In order for our enemy to have reference to all of these sprites, we need to go into our enemy's sprite, and we're going to use more of these onReady vars to get access to some of our files. Go ahead and type at onReady var. I'm going to call it idle sheet. And then I'm going to use a function called load. And I am going to pick our warrior idle.png. See it right here. Okay. Basically, what this load function does is you can pass in a string that is a path to somewhere in your file system, and it is going to load whatever that string is, whether it is a texture or a scene or a resource, and it's going to store it in this variable. So I'm going to go ahead and do that for our other 2 sprite sheets as well. So now that we have our idle animation ready, let's go ahead and get this playing in game. To do so, go ahead and jump back over to your script, and we need to get access to our animation player. So let's go ahead and do onReady var. I'm just going to call it anim player, but again, you can call this stuff whatever you want. And we're going to get access to it with our $sign and grab animation player. Now this $sign name is going to be whatever it is named over in your scene tree. If you decided to name your animation player something different over here, you're just going to use the name of whatever you've put here with the $sign. Now in our physics process, we can just go ahead and add anim player, and then we're going to call a method called play by hitting .play. And then you'll see that it gives us a list of every animation that we've made so far, this being just idle. So now when we go ahead and run our game, you'll see that he is using his idle animation as he's walking at us. Now, obviously that's not what we want him to do, but at least shows you that that's at least how you implement it. Now you'll notice, because we're calling animation player.play every single frame of the game, you would think that it would just play the same frame over and over again. But with the animation player, if this animation is already running, it's just going to let it keep running rather than restarting it every time you call it. Now, I want to go ahead and add an attack animation because this is where things are going to get particularly tricky for us. If you go back into our animation player, either by clicking on animation down here at the bottom or by clicking back onto the animation player, let's go ahead and add our attack animation. So we'll click animation, new, we'll just call it attack. And let's go ahead and set our sprite to our attack animation. So we can go ahead and clear this out with this return button. And let's move over. We're just going to use attack 1. You'll notice that this sprite sheet only has 4 frames as opposed to our idle animation, which had 8. So what we're going to do, we're going to make this last 0.4 seconds. We're not going to set it to looping because when he attacks, we only want him to attack the once. And let's go ahead and key our frames. 0, we're going to key frame 0. Oh, I don't know why I did that. You can drag these around if they place it in weird spots, okay? And then go back to your sprite, then we're going to key frame 1, frame 2, and 3. Okay, so now if we go to our 2D and we look at this, we can see that it looks really wonky. We're only meant to have 4 H frames, and instead we have 8. So something else we can do, we can key this property as well. We want this to key over at the beginning though. So if you want to key that at the beginning, you can move this track player all the way to the beginning or just drag it over to the front. And when you click on this property, it'll tell you what value we want it to set at. So this is the time at which it's going to occur. We're just going to go ahead and set this value to 4. And when we do this and we play our animation, you can see that it now looks normal. But now after we do our attack animation and we go to our idle animation and we play it, just to show you, I'm going to reset our sprite to our idle animation. We're going to be changing this out in code. If I put in idle, you'll see now it's playing 2 frames side by side because it thinks we only have 4. So when you make these changes in your animations, you might have to go back through all of your animations to add these properties in. Just keep that in mind. So we're going to just go ahead and we're going to add the same property. And we know that the value is supposed to be 8 for this one. And now when we play it, it plays right. We can stop it, go back to our attack, play it, go back to your attack animation when you have the right sprite in, and you'll see that it plays right. So now that we have these animations working when the right sprite is in, let's in code get the right sprites in when they need to be. To do this, I'm going to create a function called change state, where I think our character is going to have effectively 3 states: an idle state, an attacking state, and a running state. What I'm thinking is that he is going to run at the character. When he's within a certain range, he's going to switch to his attacking state and he's going to swing. And then after he swings, he's going to have some idle time where he's not going to be moving or attacking, like a sort of cooldown period. I'm just going to go ahead and put pass in here for now. Oh, you'll see I accidentally left this in when I was testing this out. Go ahead and add class name swordsman or whatever you want to call it to the top. Remember that I think you should probably be putting class name at the top of every single one of your scripts. It's just going to make all of your methods and properties much easier to access when you're working with other scripts. The other thing I threw in here is I threw in an enumerator. The way to define an enumerator is a little bit different. You'll see that we have enum and then what our name for it is. I've done it in all caps because it is a constant variable. And then rather than putting an equals sign, you'll see we use this curly bracket here. This doesn't really mean anything special to us, but it means something to the compiler. All we need to understand from it is that everything in this curly bracket is going to be a part of a list. And then every item in that list should be separated with a comma until the end. For code organization, it's very common for you to type in like one of these states, throw in your comma, and then if you had a different state, you would add that in, comma, and you're going to do this on a new line for every single one of these. You don't have to. You could have these all on the same line. For a small state machine like we're going to be having, you could definitely run it all on the same line. This is the common way that people do it to help make it more readable. So anyway, what we're going to do is in our change state function, we're actually going to be able to call this from our animation player, and we're going to have it do certain things based on what state we're changing to. So I want us to pass in an argument, which is going to be what state we're changing to. We're going to call our argument new state, and we're just going to set it to type state, which is our enumerator here. Enumerator values, you can type in any word you want for them. They're basically like variable names, but they're actually just integer values under the hood. So this is a 0, this is a 1, this is a 2. And then in here, we can choose what we want to do based on the new state that our animation player is going to be telling our enemy to change into. So we can say if our new state, and we use double equals in our if statements to check if something is the same as something else. So if our new state value is going to be equal to the run value, state dot run, we put a colon after this to show that that's the end of our if statement, tab it over, it should do it automatically for you. And then for now, I'm just wanting to change our sprite to our run sheet. So let's go ahead and get access to our sprite with another onReady var. And I'm going to change our sprite.texture property, because remember, we want to change out this texture to the right sprite sheet. And I'm going to set this to our run sheet. And I'm going to do the same for each of our other states. So we can say elif. Elif occurs if you check this if statement and it returns false. So if new state is run, if it equals run, then we're going to do this line of code. Otherwise, we're going to keep checking down the list of elifs. This is short for else if. So then we're going to write in our new condition. So if the new state is equal to attack, then we're just going to set our sprite texture to our attack sheet. And then at the very end, as a catch-all, you can use something called an else statement, which means if everything else above this has returned false, just go ahead and run this guy. We know that we only have these 3 conditions, so we know that this else is only going to catch idle, but it's worth still seeing it. And so we're just going to set our texture to our idle sheet. So now that we have this state set up, what we can do is go back into our animation player, and we can add a method track, which is going to let us call functions from our parent node. So we're going to add this method. We're just going to click on our swordsman node up here at the top, and we're going to right click here at the very beginning, and we're going to insert a key. So you'll notice it gives us our script methods, which is everything that we've added to it. And then it also gives us the methods of every inherited node that this object comes from, okay? So this can be made into something very, very dynamic. We're just going to go ahead and click our change state function. And then since this is our attack animation, we want to go into our attack state. So remember, that means that we want to pass in the argument 1 or attack in order to trigger our attack sheet. So to change this, we're just going to go ahead and click on the key right here. And you'll see that we have something called an argument count, which is the number of arguments that we're passing in. And we're only passing in just the one argument, just our new state. And then in our arguments, for argument 0, which is the first in our list of arguments, we are passing in an integer with the value of 0. But we don't want to do that because 0 in our case is run. So we're just going to go ahead and increase that to 1 so that it does the attack animation. And then we're going to do the same thing in our idle animation, where we're going to add a method track, connect it to our swordsman node, right click to insert a key on the track, connect it to change states. And since this is our idle state, which is state 2, because remember 0, 1, 2, we're going to go into our arguments and we're going to set this to 2. Let's go ahead and just make our run animation while we're at it. Go over to animation, click new, call it run. Let's go ahead and switch our sprite out for the run sheet. You'll see that this is a 6-frame animation. So let's go ahead and set this to 0.6 seconds. And we know that we want it to be looping because this player could keep on running for a lot longer than 6 seconds. And we're going to go ahead and we're going to key frame 0 at the beginning. And we're going to run through all 6 frames. And then at the beginning, we also want to key our H frames. And we're going to go ahead and set that value to 6. And we're going to call our change state method by inserting our change state key. And we want this to actually pass in the number 0 because this is our number 0 state. So we're just going to leave that as is. So just thinking aloud about how we want our enemy to work. We want it to run at the player, which is what we've done with this function here. When it gets in range, we want it to attack the player. And then after attacking, we want it to kind of chill for a bit. So to me, that tells me the next thing that we need to mark on our list is we need to know when the player gets in range. Let's go ahead and we're going to add a node called an area 2D. This is a collision object, but rather than something actually colliding with it in the same way that we have just done with our character bodies and our static bodies in our rock and tile map, an area does not stop anything from passing into it. It only sees when something is inside or outside of it. So I'm going to go ahead and set this collision to be looking for the player, and I'll put it to just exist on the enemy level, though I don't think technically you need to set a collision layer for it to live on. You only need it to be looking for something. And you'll see that it's throwing the same warning that our character body did, that it is looking for a shape. So let's go ahead and throw on a collision shape 2D. And I'm also just going to make this a circle. Okay, so it's going to be a little bit challenging for you to see what you need this to be based on what we're looking at here. It's going to be a little hard to tell how big you need this radius to be without looking at the actual attack frame of your sprite. So we're going to go ahead and set our texture to our attack animation. And we're going to bump our H frames down to 4. And remember, it's okay if we change all these things here now, because our animation player is always going to correct them when we call it back. So let's go ahead and set our sprite to our largest attack animation, because I'm just curious how big it needs to be. So we should try to call our attack when the player is in this radius. So I'm going to go ahead and bump our circle up to be about the size of our attack animation. I think that looks pretty good. So now we're going to go back to our script. We need some way to still get that information. So now we have an area that will detect it, but now we need to get that information into our script so we can do something with it. One of my favorite features in Godot is their signal system. So if you go and click on your area 2D, go over to node and click on signals, it will give you a list of every signal that it has. And effectively what this will do is let everything know that's connected to the signal when a certain thing happens. So the area 2D node is always checking if something is coming in or out of it. But to let other things know if that has happened, you can use these functions, area entered, body entered. We're going to be using body entered because we are only checking for the character body. So if you double click on it, it'll open this window. And it is going to create a function for us in our script called onArea2D body entered. That's because we have an area 2D or we're connecting the signal body entered. This will, however, detect when anything walks into it. We do have our collision mask set to only check for the player. So in theory, the only thing that should be allowed to enter this and trigger this signal is the player. But because I'm paranoid and always want to make sure that nothing unexpected happens, I'm just going to say if body dot is in group and then the string name of the group, which is player. Is in group is a really handy function for quickly getting access to specific types of nodes. So now that we know that we're only going to be calling this when the player is in our range, I'm just going to go ahead and say animPlayer dot play attack. Something for you to understand about programming as a whole. There are a million different ways to solve all the different problems that come up in a game. The way that I'm doing it is not always going to be the best, and this probably isn't the way that I would be doing it in my own games, if that makes sense. Probably what would normally happen is you would call your change state to attack here, and then maybe in your change state, you would change your sprite sheet as well as call the attack animation. And then in your animation player, you wouldn't have to worry about keying in methods. Some of this stuff I am doing just to demonstrate all of the possibilities with the engine. My ultimate goal for this series is that you guys don't get stuck in tutorial hell and just keep watching tutorial after tutorial and hoping that eventually you'll learn. I'm trying to give you the foundation of everything you need to know about Godot in order to get started on your own games. And I think in order to do that, you have to have a good understanding of all of the tools at your disposal. So yeah, if any of this ever seems weird to you guys, it's probably just because I'm trying to show off different pieces of the engine. Okay, when I was testing this, I noticed that I did something really stupid. I accidentally changed the size of my character's collision shape instead of my Area 2D's like detecting shape. So if you run into this issue where it now seems like your player is getting stuck on things that he should not be, that's probably what happened. Fix that. I'm just going to take our actual area collision shape and I'm going to draw it up to the size of the collision shape that we made because I liked the size of that. And then I'm going to go to our other collision shape, change it back down to a dot, but I'm going to have to change the sprite back to the idle animation in order to get that size just right. Okay, I think that's what we had it at. Then in our script, to make sure that this is actually going to work, we need to take our animation player.play idle out of our physics process. Because now what will happen is our player is going to walk into range of the enemy. He's going to trigger his attack, but then immediately in the next physics tick, he's just going to go back to playing idle. So I'm actually going to move animation player.play, and I'm going to change this to run to begin with at the very beginning of our scene. And then if we play it, see he runs to our player, gets in range, and does an attack. Perfect. And I don't think that I want him running while he's attacking. So I'm going to move all of our navigation logic behind an if statement that says if current state is going to be equal to run, then your navigation. So now we need a variable called current state, which is going to track what state we're currently in. I'm going to go ahead and just create a bar up here. And remember that I'm doing it up here in the global scope of this script so that I can access it throughout my functions. I'm just going to call it current state. And I'm going to make sure that it is going to be set to a type of state. And then in my change state, I am going to set at the bottom of this that current state is just going to equal our new state. And if we try that out again, we should see that our enemy stops when he swings at the player. Perfect. Now we're going to need a way for the enemy to enter some sort of cooldown state where he's sitting there and idling, and then we'll resume his walking. So I'm going to add a node called timer, and I'll leave it at 1 second. That sounds fine to me. Actually, I'll set it to 0.8 seconds because that's the length of our idle animation. We might do that in code though. And I'm going to connect a timeout signal where basically all this timer does is you start it, it runs, it stops, it emits this timeout signal, and then you can do some things when it ends. So I'm going to connect on timer timeout. And in this, I am just going to change our player's state back to running. And this is going to work for us because remember, all of our navigation is stuck behind if our current state is running. So when we change our current state back to run, all of this code is going to start executing again. So what we can do now is once our player attacks, we know that we want him to enter the idle animation. So at the end of our attack animation, since we know that we want our idle animation to play at the end of our attack animation, what we can do is connect another method track. We'll actually add a new method track because we're going to be calling this method from another node. We're going to be calling our play function from our animation player. So at the very end of this animation, we are going to insert a key, and we're just going to use the play function that we've been using otherwise. In our key, we can look at our arguments, and remember that the very first argument that we've been modifying is the string name of the animation that we want it to go to. So in here, we can just type in that we want it to play the idle animation. And so now when he attacks, he's going to immediately start this animation, and he's going to enter his idle state until it completes. Now, what we could do is at the end of our idle animation, we could also just start calling the run animation at the end of this instead of having it connected to a timer. However, maybe we have different types of enemies that have different cooldown periods, or maybe 0.8 seconds is too fast or too slow, and we want to have a little bit more flexibility to adjust that. That's why we would move something like that out of the animation tree and into a timer. So with that in mind, we also know that at the end of our attack animation, we want to call timer.start, which is going to start our timer for our idle animation duration. So we're going to do the same thing. We are going to add another method track from our timer. We're going to insert a key at the end of our animation, and we're going to click on timer start. Now, in order to get our timer to work the way that we want it to, we're just going to leave it at 0.8 seconds, and we'll see how we like that. You can tune that for your game depending on how you like it. We have some other functions here. We have one called one shot, which we want to turn on. If your timer is not set to one shot, once you start it, it's going to keep going and going and going. Auto start is another function you might want to have on some of your timers. We don't want it in this case, but it will start immediately on ready. So now what we should see happen is our player or our enemy run to our player, get in range, attack. Once he finishes the attack animation, he will start idling until our timer goes off. And when our timer goes off, it is going to emit this signal, timeout, and it is going to put us back into our run state. So let's go ahead and test out and see if that works. Stands there for a second. Oh, here, let me move away from the... Interesting. He doesn't seem to want to run again. I'm going to include this little bit of debugging that I'm doing. Normally, I would just cut all this out and show you guys how it actually works. But whenever you're making your own games, you're going to run into crap that's going to go wrong all the time. And I think it's really valuable to know how to solve it. So the easiest way to find out where things are happening in your code is with print statements. You can have it print anything that you want it to say. But basically that'll show you in the output that your code at least made it to that point. So I'm curious if our timer actually started and triggered our run state here. So I'm going to go ahead and print here. So that way I know whether or not the enemy got in range, attacked, and started the timer. Okay, yes. So that timer did go off, which means that in turning back into the run state, something went wrong. To me, I feel like the simple solution is just getting our animation player to play run. And then at the start of our animation of run, we change to state run. So we probably don't actually need this line of code, and we probably don't need to print anymore. And something tells me that's just going to work. So he does this attack, he waits, and he runs. Very good. And he'll just keep doing that over and over. Perfect. That's exactly what we want to see from him. Fortunately, that was a really easy issue to solve, but normally in debugging, you're going to want to go through and test like methodically through all of your steps and be like, okay, did this actually happen the way I expected it to? Yes. Okay. Next step. Did this happen the way that I wanted it to? Yes. Okay. Next step. And then you'll go through every single step. Fortunately, our character is very basic. He only does one very simple thing of chase, swing, stop. So it's very easy to diagnose where in there the problem is happening. Something else you can do that's pretty handy is if you're in your script editor and you go over here on the left, you can actually click a red dot here. And what will happen is whenever the enemy or whenever that line of code gets triggered, your whole game will stop at that breakpoint. And that's just a handy way also if you don't want to have to print stuff to make sure that your game made it to a certain point. Okay, I think we're going to go ahead and stop there for today. Next time, we're probably going to animate our player and make him start attacking the enemy. Thank you guys so much for supporting my channel and supporting this series. I'm super appreciative for your time, and I really hope that you find these tutorials helpful for you in your game dev journey. If you liked the video, as always, drop a like, and if you have any questions about any of the content that I covered in this video, please ask in the comments. Thank you so much again. Take it easy.